Welcome to Quality Branding Hub. The channel is for the quality control engineer, site engineer, and the civil engineer who are working in the construction field. In this channel, we are dealing with anything and everything which is required to get success in the construction. Today also, I'm going to discuss about a very fundamental topics of the construction, that is reinforced cement concrete. Now, it is without a concrete, even we cannot think about the projects. Every project, the main pillar or the main backbone is the concrete. But why alone concrete cannot sustain, or alone concrete cannot give the structural stability? That is why we need to introduce, or we need to embed it steel inside the concrete. And what is the reason behind it? Why only steel, not any other metal? In today's video, I will discuss each and everything in detail, so stay tuned until the end to get the full information. And if you are new in my channel, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. So today's topic is, why is reinforcement used in concrete? See, concrete alone cannot take the load or cannot give the structural stability. That is why reinforcement is embedded. But what is the reason behind it? So one by one, let us break it down. The first thing is, the concrete is weak in tension. That means when a structure is subject to external load, that the tension and the compression stress will generate inside the structure. Now, to withstand or give the structural stability, the structure needs to withstand both in tension and both in compression. But in the concrete is a brittle material, excellent in compression, but it very much poor in tension. So what is the strength we are calculating or we are getting? That is M25, M30, M40, M45. That is the compressive strength. That means it has a higher compressive strength, but it's a very poor in tension. But no, not a single structure will be only the compression. There will be a tension. So if we need not to withstand the tension, that the structural stability will be a problem. So that is why we need to increase the tension property or the tensile strength carrying property in the concrete, so that it can withstand the load. Its tensile strength is typically just 10 to 15% of its compressive strength. Without reinforcement, concrete would crack and fail under tension or bending. So that is why we start to introduce reinforcement inside the concrete to take the tensile load what is generating into the structure. So example, we can take a simply supported concrete beam. Under load will develop tension in the bottom fibers. Plain concrete alone would crack and fail. So to resist that one in the bottom area, we need to produce or we need to embed the steel, so that the tensile load carrying capacity also increase. So first point is, concrete is weak in tension, then steel is strong in tension. Now, steel reinforcement or rebar has very high tensile strength and excellent ductility. When embedded in concrete, it can carry the tensile load that concrete cannot. Steel can also take some compressive and shear loads, improving structural performance. So what is our structure? It has compression, it has tension. So both the load you need to carry. So one material, that is a concrete, that is taking the compressive load, and who will take the tensile load? That is why the steel, because it has a very high tensile strength, which is not in the concrete, which has the higher compressive strength but lower tensile strength. So in combination, in the concrete or steel, both the tension and the compressive load is carrying, and the structural is stable. So these are the main point, that the concrete is weak in tension and steel is strong in tension. So in combination of concrete and steel, the RCC or the reinforced cement struck concrete can take compression and as well as tension. So composite action, concrete steel plus steel is equal to RCC. So it's become a composite material, that is a concrete plus steel. When steel bar are placed strategically inside concrete, usually a tension zone. And what is tension zone and what is compression zone? That means when the load is coming into the structure, takes up on a simply supported beam, when it is coming the load, the bottom fiber is becoming tension and the top fiber is becoming the compression, depending upon the load pattern. And so the bottom part is becoming the tension zone and the top part is becoming the compression zone. So inside the concrete, in the tension zone, you need to introduce or you need to embedded steel so that the tension strength it can carry. Together, concrete and steel form a composite material known as reinforced cement concrete, or the RCC, and this in synergy allows structure to span longer distance, carry heavier loads, withstand complex stress combination, that is bending, shear, tension, and also compression load. So in combination, we are making a composite material, that is a reinforced cement concrete, whereas the concrete and the steel is there. So both the load, that is in tension, and the compression and the shear, that can carry effectively, and our structure can stay longer. The next part is strong bond between concrete and steel. Now, we have already found out that concrete is in weak in tension, but steel is stronger in tension. So in between together, we can make a composite material, that is reinforced cement concrete, that can carry. Now, the steel is a foreign material inside the concrete. Now, the steel needs to bond very properly into the concrete. Otherwise, if there's a bonding is not proper, then again there will be a problem. The cracks can generate and structural stability will be a problem. So concrete adheres well to steel due to chemical bond, mechanical interlock, especially with rib and twist. So we need to think about the how they bond together. If the bonding is not proper, then they will not act as a composite material. Then what is our purpose? That purpose will not solve. That is why it's chemical bond and a mechanical interlock. Similar thermal expansion coefficient which prevent internal stresses due to temperature changes. Now it is a very much important. That is why steel being used in the concrete and not in the other metals. Why? Both the concrete and the steel has similar thermal expansion properties. So due to the temperature changes, it will expand or contract in the similar way. So that is why the internal stresses will not generate due to the temperature changes, and that will not, the internal cracks or internal failure will not happen. Both material expand and contract similarly with temperature 12 into 10 to the power 6 centigrade. That is the thermal coefficients of steel and concrete. It's very similar. If it is not similar, what will happen? The concrete and the other metal will expand and contract differentially. And if there is a differential contract or expansion, then the cracks will generate, because that both are not acting similarly. Then the internal stress will generate and there will be cracks in the concrete and our structural stability will be the problem. So it has the very good bonding and the similar thermal expansion property. Otherwise, we cannot think or we cannot even use inside the concrete. The next part is durability and protection of steel. See, here it is a very important part that steel is nothing but iron, and it has a tendency to make rust when it is come to the contact with the steel or moistures and the oxygen. So it has a tendency when the inside in the concrete, if any moisture is ingresing inside the concrete, then it can rust, and the tensile property of the concrete can be deteriorated, and also due to the volume changes, it can crack the concrete. So when embedded concrete, steel is protected from a corrosion due to alkaline nature of concrete. So concrete pH is 12.5. That's highly alkaline. So when this highly steel is embedded inside the concrete, this highly alkaline property is making a film around the steel, which is protecting steel from the corrosion. So this also helps that make a composite material. Concrete cover shell reinforcement from moistures and aggressive agents. Adequate cover and mixed design improves service the life, that RCC structure, that is a separate part. But the durability or the protection of the steel also helps due to the concrete high pH. If the pH is low, then this protection of film will not be there and the steel will get corrode. And if it is corrode, our concrete structure will not be given the structural stability. The next part is control of cracks. Now another part is, if there is only only cement concrete that prone to crack due to the tensile force, so it's control and limit the cracks, keep cracks within permissible widths, maintain aesthetic structural safety. So what is the internal stress will generate, that will also take care by the reinforcement, so that the cracks will not generate. So that is why also we need to install or embed the reinforcement bar. The next in resisting shear and torsion. See, on in the structure, not only the tension force, not only the compression force. We are talking about the tension and force compression, but there is a shear force and also torsion also. That also we need to take care. Otherwise, our concrete or the structure will not be stable. So, special types of reinforcement, that the stirrups, ties, spirals. Why you are using that one? Resist shear forces, provide torsional resistance, impact ductility, and seismic performance. Not only the main river, whatever the stirrups we are using, that is also help us to resist the shear force, torsions, and the seismic load. So that is why it also helps to resisting shear and torsion. Then enhanced seismic performance. This seismic zone reinforcement improves the energy dissipations, ductility, and resilience. Still, special ductile detailing is done as per IS 13920 to avoid collapse during earthquake. So earthquake is become a problem. So if we are not thinking about the earthquake resistance, then our structure can be unstable during the earthquake. So that is why we need to introduce steel, and the steel help us to fight against the earthquake. So it is enhance the seismic performance as well. The next is flexibility in design. Why? With reinforcement, engineers can build long span bridges, high-rise buildings, and complex shapes. Without the steel, the span will not be that much. And then optimize the material uses, achieve better economy, functionality, and aesthetics. That is also a part that it can help our concrete or the structure life longer. And the relevant IS code, there are IS 456, IS that is design and construction of RCC structure, IS 1786 2008 steel for reinforcement, 13920 that ductile detailing of seismic structure, 2502 bending and fixing of river. So these are all about the why reinforcement used in concrete, why not other material. I hope you find it useful, and if you find it useful, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. And I'm waiting for your valuable comments, so that from your valuable comment everybody will be benefited. And if you want to know anything more about quality control and construction, please let me know. I will come with more content like this. And thank you once again for watching me.